Welcome back to Astronomy 104, the astronomy of planets. Well, we've reached the end. If I could briefly summarize the material covered so far, I'd say that the course has been about learning what our solar system is, how it formed, and how it's evolved since then. We began with the basics, with the development of the scientific method, the discovery that the Earth is a planet that orbits the Sun along with 5 other planets that people knew about at the time. And then we talked about the tools that astronomers use to investigate the sky, telescopes, light, and the way that light interacts with matter. In the second half of the course, we explored what has been learned about all the planets, mainly in the last half century, since space missions have been sent out to study each of them. And in the last module, you saw how all that information is incorporated into models that describe the solar system's formation and evolution. The next step beyond our solar system is to study other solar systems. We do this partly because we're curious to know what else exists out there. Are we alone, or is the universe filled with life? But we do it also because everything we can learn about other planetary systems helps us to understand our own that much better, just as studying the other objects in our solar system helps us to understand the Earth better. This is really the same aspect of astronomy that you first encountered in the learning material, that it's by studying the universe around us that we're able to learn about ourselves, where we come from, and what our place is in the bigger picture. You've seen quite a few examples of how this works. For instance, you found in Module 7 that by comparing Earth to Mars and Venus, we can better understand how our planet manages to sustain liquid water on its surface. Or as you saw in the last module, by studying our planetary system as a whole, we've been able to understand why Earth formed as it did, with a solid surface and relatively little hydrogen and helium. In this final module, you will therefore look at what astronomers have learned about planetary systems beyond ours, which they've learned both because they're curious to know what else exists out there, and also because they know that the information will help us to better understand what's going on right here and now. The study of extrasolar planets, or exoplanets, is really new. The first one discovered in orbit around a regular sun-like star was only detected in 1995. In this module, you'll learn about this discovery and others. As you do, you probably won't be surprised to find that our solar system is not representative of every other one that exists, that the rules of planetary formation produce a lot more variety than scientists had even suspected before they started making these discoveries. Actually, you'll see that the first planetary systems discovered were so bizarre that planetary scientists had thought they couldn't possibly exist before they were observed. And you'll see that these discoveries have actually already had a large impact on the way we understand our solar system. After studying some of the history of these discoveries, the various techniques that astronomers have used to make them, and the current status of exoplanetary research, you'll end this module with a discussion. The purpose of this discussion is for you to take a step back from the course, to think about what astronomers have achieved in terms of developing our knowledge about the world and what we hope to achieve through continued exploration, and to contrast this one perspective that you've been hearing throughout this course with other perspectives of people who maybe aren't all that interested in the results that astronomers are seeking. Once you've written your discussion post, you'll have reached the end of the course material. I hope you enjoyed the class.